Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and I am stoked to be here with you. Stoked is such an old school word. It comes from my childhood. I don't think any of you used that word. I think it's a sign of my age, but that's okay. I'm excited to be here with you in this series of videos delving into what you can expect in your grade 11 paper 2. So this is now again answering questions about the Department of Basic Education, paper 2, but I'm also going to go from this question paper to one or two other question papers so that you can get the best value for your money, even though you're not paying anything for this. Ladies and gentlemen, our first video is going to talk about statistics. I'm specifically looking at mean, variance, and descriptive stats. This is something very close to my heart because I've come to realize you guys are fantastic at punching those calculators and using them to get answers. But when we ask students, what does it mean? You're kind of lost for words. So I want to delve into this by looking at this specific example. So hit the pause button, get those calculators ready, and try it yourself. When I look at something like question 1, it's actually a really simple question, but I am going to, of course, delve deeper into this and explain some of the nitty-gritty things. But let's start with the basics. It says here the data below shows a number of people visiting the local clinic per day to be vaccinated against COVID-19. Determine the mean of the given data. I love to not just use my calculator and get answers. I'm fine with it if you do, but please, the examiner can ask a question in such a way that you actually need to know how to use the formula. So what is the formula for mean? Well, adding the numbers, dividing it by how many numbers there are, and that gives me the mean, which is 408 over 19. This means that 21,47. Let's hit the pause button. That means on any random day, I could expect 21,47 people. Now, I know that you might look at this and go, but so you can't have a 0.47 of a person. But remember, this is descriptive. It just shows that it's more than 21, but less than 22. A lot of statistics actually gains sense or gains a meaning when we start comparing values with other sets of data or with what we accept to be a standard. So for instance, if the normal set, if there's the average person clinic-wise was 20.5 people that walked into a clinic, and this was done on a big scale, you would compare that to the 21.47 to see whether it corresponds. Well, this means if the norm was 20.5, but this is 21.47, you would say, wow, this clinic is doing fantastic. It's a very busy clinic. But if the norm was 40, then there must be some kind of thinking about why. Is it maybe a very slow area? Maybe the people don't know about it. Maybe the people don't like the vaccine, because remember, we're now talking about vaccinated against COVID. Now you can start delving deeper about why is this maybe not the way that the other clinics are working. And that's where statistics is pointing us towards. Before I go down this rabbit hole even more, let's look at the next question. Calculate the standard deviation of the data. Now, the standard deviation, ladies and gentlemen, is, it's a nice, meaty, wonderful calculation. But the formula is the following: sigma of x minus x bar squared over n. Now you're like, sure, so, but my teacher said that they won't ask the formula. But actually, the IEB a year or two back actually asked this formula like this in the exam. They gave the students the numerator and gave them n and asked them to calculate sigma. That was asked. So please understand that this formula, even though we don't manually go and say x, so the 5 minus the mean 21,47, we square it and then add to that the next number, 12 minus 21,47 squared plus, and that is what gives me this top part where it tells me that actually that is 1058,73 over 19, which gives me a sigma of 7,81. Please, especially if you're in an IEB school, they can ask you to use the formula for sigma. Because it has come up in the finals, I know your teachers look at what's happening in the grade 12 finals, and then they sneaky bring it in because they don't want you to be caught off guard. But what does all of this actually mean? Let me explain this. What it actually means is that if I take the average or the mean or the expected value, all three of those words have the same meaning. And I take one standard deviation above the mean and one standard deviation below the mean. So in other words, between 13,66 and 29,28, it is actually going to give me the majority of the data is going to lie in that specific area. So in that area between those two, the majority of the data is going to lie. But what does standard deviation give me? Standard deviation points, okay? So let's quickly talk about this. Standard deviation, ladies and gentlemen, points towards consistency. Okay, let me just write it correctly. Consistency. While your mean talks about outcome. Okay, it's the expected outcome. So if I have a high sigma, that is the little cherry, that's standard deviation, it means the person is not very consistent. If I compare it maybe to someone with a small standard deviation, let me use an example. If I compare two people with the same average in their overall average mark for their exams, but the one person has a high sigma and one person has a low sigma. If the person has a high sigma, it means they're going to score very well in one, but not very well in the next. So it's going to be spread out. Where if there's a small standard deviation, a small sigma, it means they are consistent. So it means that they always score roughly the same, around about your mean, much better than the person with a higher sigma. But let's talk about what variations in questions I've seen in exams and I've asked in the exams. What if I insert 90 into this specific standard, into this entry, this data set? What would be the effect on both X bar and mean? Remember, or your sigma. In the mean, as well as sigma, because the 90 is so far out from where the rest of the data lie. I mean, the highest data is in the 30s. So that 90 is like way off. It is going to mean a higher expected value because all of a sudden now you're introducing a huge number. But also it's going to make the rest of the data less consistent. It's going to be more spread out because it is an outlier. Now here comes one of our favorite questions. What if I decrease each number by 5? What is the effect on the mean and the standard deviation? So let's talk about the outcome, the expected outcome, the mean. If I decrease each number by 5, well, that means the expected outcome is going to be lower because everything is decreased by 5. So in other words, my x bar is going to decrease by 5. My mean is going to decrease by 5. But what about my consistency? My consistency is exactly the same because they still are spread out the same way, but everything was now moved lower. This is the kind of question that I love to ask and I can expect the examiner to also ask. Let's have a look at the next question. Oh my goodness, look at 1.3. How many people lie within one standard deviation of the mean? Well, let's look at the data. There I've circled all of the ones that lie between 13,66 and 29,28. And I just want to quickly say this, and you don't have to believe me. But as I was writing out this video, I didn't even realize that question 1.3 was going to ask this. But this is the way that I've just seen so many times that it happens. And I've always asked these kind of questions. And it's also good for your understanding why we do standard deviations. So that means there are 13 out of the 19 that is going to be within one standard deviation. Simple and as easy as that. Now 1.4, it says there, determine the interquartile range for the data. So the interquartile range, I'm going to first of all have to write out all the data in ascending order. Now you will see I love to kind of pick the numbers out and cross them out, making sure I end up with 19 numbers at the bottom. So going for interquartile range, I must first find my median. So front, back, front, back, front, back, all the way into the middle. Then repeating that process. Okay, let me just maybe go back a little bit. After I found my mean, remember, I've now used it up, or not my mean, what am I talking about? My median, my middle number. Remember, I've used it up. I can't use it again. So then I'm going to repeat this process with the front half, so looking from 5 to 20. And I'm going to repeat this front back process until I have now found Q1 as being 18. Then I'm going to repeat this process again from 21 to 37. Front, back, front, back, front, back. There's my Q3. But the question is interquartile range. So I'm going to take Q3 and minus Q1. After doing this, I found my interquartile range is 8. At 1.5, it now says take this data and draw a box and whisker diagram. So I take my number line. Remember, it has to be on scale. I'm going to start by plotting my lowest point, which is 5. My highest, or let's do my quartile 1, which is 18. My median, which is 21, and my upper quartile, my quartile 3, which is 26. Next up, I'm going to do my highest value. There we go, 36. Okay, there we go, 37 I mean, my apologies. And then I'm just going to draw my box and whisker. Last question for this one is identify any outliers. Now please understand that an outlier is not just about the length of your whisker. An outlier is a number that doesn't fit any other data points. It doesn't fit. Now, I'm not saying that's a formal definition. Please, there might be some ways in the textbooks or in other textbooks to specifically calculate outliers. But remember, this is a 1-mark question. An outlier is just a set of data that doesn't fit. And the only one that doesn't have any data close to it is the number 5, because there's no other number that comes close to it. The closest number to 5 is 12. If I look at why is the 37 not an outlier? Close to 37, there's 35 and 33. So it's definitely not an outlier. That's why I would say 5 is the only outlier because there's no other numbers that's close to it. Wow, what an awesome video. I hope that you gained some understanding about mean, about standard deviation, and how teachers can ask it in different ways. Have a beautiful, amazing rest of your night. This is Mr. VG signing out. Cheers.